Hello everyone. In this video clip, I am going to show you how to differentiate the x cubed expression using the first principle. Okay, so to start off, we have to create a point that is very near to the original xy, because we must remember differentiation. The objective is to find the gradient of a curve at one point. So in order for us to find the gradient, we need to create a nearby point, and let's do it. So that is the reason we take y plus del y, but very small changes in terms of y. And at the same time, the x will also experience the same changes, which is x plus very small changes in x, so cube plus 9. Now let's expand this. How do we expand this? X plus del x can be written as x plus del x times by itself for 3 times. And I can just write like power 1 of x plus del x times with square of x plus del x. And then plus 9. Next, okay, we can find this using the formula, which is x squared plus 2 times x times del x plus with del x squared. Okay, use the square brackets. We have another round bracket inside. Okay, so this is actually the formula that you learn in Form 3. When you have a linear expression, 2 terms, yeah? When you square it, the formula that we use is a squared plus or minus, depends on plus or minus in the center, 2ab. Take 2 times the a times the b, and then plus b squared. So this is what I am applying to solve this part. And after we have expanded that, we can now expand this part. Okay, so we will have negative 5 x cubed plus 2x squared del x plus x times del x squared, and then followed by the del x times the same expression. Okay, so we will have plus x squared del x plus 2x times del x squared plus del x cubed. Okay, and then plus 9. So let's simplify it inside the square bracket. We will have negative 5 x cubed. The 2x squared del x, we have altogether 3x squared del x, and then x del x squared. We also have 1 plus 2, so we have 3x del x squared. And finally, it is del x cubed, and then plus 9. Let's open up the bracket, negative 5x cubed minus 15x squared del x minus 15x del x squared minus 5 del x cubed plus 9. Okay, so this whole thing is actually y plus del y. Now notice that we can see minus 5x cubed plus 9 in the expansion that we just did. Okay, and then do you notice that this one is actually the y, right? Let's write this one. So we will have y minus 15x squared del x minus 15x del x squared minus 5 del x cubed. Okay, so we have both sides contain y, so we can just cancel the y. And what we left is just del y. Now, in order for us to find dy dx, we must first divide both sides with del x. Yeah, you must know the relationship between dy by dx with del y by del x. They are not equals, okay? We have to put equals after we set a limit that del x approaches 0, okay? When without the limit, dy by dx will be just approximately equivalent to del y by del x. Okay, so for this one and this one, it has huge difference. Yeah? Okay, so the first principle, we'll be using this one. Let's divide both sides with del x. First, we will have negative 15x squared minus 15x del x minus 5 del x squared. And let's apply that. Dy by dx equals to, all right, it will be equals when we set the limit when del x approaches 0. So negative 15x squared minus 15x del x minus 5 del x squared. Del means delta, yeah? And then when we substitute del x equals to 0, we will get this 0 and 0. So what we left will be just negative 15x squared. We have just found the differentiation by first principle using this way. Now, for us to expand this, okay, we have actually have another method which you have learned in Form 1, Form 2, sorry. Do you still remember the Pascal's triangle? Actually, the Pascal triangle will help us to ease our effort in expanding the algebraic expression. Okay, let's recall. Okay, this is how our Pascal triangle look like. Both ends should start. Both ends must fill up with 1. So the one in the middle will be the sum of the two previous number. So how does this related to our formula of this? It is actually the coefficient. It is actually representing the coefficient of our a plus b to the power n, whereby the first layer is 0, the second layer is power 1, okay, the third layer is power 2, and then a plus b to the power of 3, if we want to expand it, we will have 4 terms, whereby the coefficient for each term will be 1, 3, 3, 1. That means it will be like this. We will write the first one, a to the power 3. The total power must be 3, followed by the a will reduce its index, its power, whereby b will increase its power. The total must be power 3, okay, followed by b squared, and finally b cubed. And therefore, the coefficient for these are 1, 3, 3, 1. Since it's plus, so all the way we should plus it. Therefore, after we expand this, we will get x cubed, 3x squared del x, 3x del x squared, and del x. So this is how we can use the Pascal triangle without going through the expansion of the x plus del x when we cube it. Okay, all right, so I hope this video clip can help you to see how we solve the differentiation by the first principle. It all go back to the basic concept that dy by dx is equivalent to del y by del x when we set the limit for the del x to approach 0. Okay, so with that, thank you very much, and I'll see you in the next video clip.